In the previous video, I illustrated how I used the cursor to offset the background from the data so that I could get a good fit of this very Lorentzian line shape to this very Lorentzian data. In this video, I'm going to illustrate how I can do this in a less manual way by introducing additional components to the peak model. And the components that I'm going to add will be related to the background and offsets in the data. I'm now going to make adjustments to this peak model so that we can, instead of using a background that is calculated from the region, I'm going to set the background within the region to be 0. And this means that if I look at the data and relative to 0, the peak model now consists of a background that has no relationship whatsoever to the data, on top of which there is a component that relates to the data but is unable to fit the data because of the absence of the background. So to rectify this, I'm going to add a component which will represent a Shirley background. And then I need to adjust this so that it has all the same characteristics of the Shirley background that was calculated from the data by fixing the full width half maximum relating the calculated background to the data itself, and also forcing the position of the background to be beneath the peak itself. The area, well, that's something that needs to be determined to allow a fit to occur. So we saw in the previous form of this analysis that we needed to have a significant offset away from 0 for the Shirley background in order to make the fit occur. So that requires another component, which is essentially a linear component. It's a trapezoid line shape, which is basically a straight line that will now adjust according to the optimization parameters, and this will bring up the line shape that represents the photo emission peak with respect to the data so that it can be part of a fit. So we've got 3 components now. The first is the photo emission peak that represents a Lorentzian line shape, a Shirley background that is calculated from the line shape that we use for the photo emission peak, and then this linear form that will help the fit. So now when I say fit, I end up with a comparable fit to what I had before, and the only difference is that I don't need to manually adjust the start and end offset in order to achieve a fit to the data. So before I had to fit, adjust, refit, adjust, refit until I got the fit that was comparable to this residual standard deviation and this residual plot. So here we have a systematic way of calculating a background with respect to a photo emission peak that allows for an offset that is required to accommodate the line shape that we've chosen.